Hi everyone, Assalamualaikum. In this section, we will discuss how to solve first order ODE, which is ordinary differential equation. Alright, there are three methods to solve first order ODE. First method is separable equation. Second method is homogeneous equation. And third method is linear equation. So, let us check it out. Right? Alright, now let's look at the first method to solve first order ODE, which is separable equation. Right? Procedure to solve separable equation. Step 1. Separating variables x and y. Left hand side we write into the form of variable y and dy. And right hand side we write into the form of variable x and dx. Step 2. To solve separable equation, integrating both sides. For left hand side, we integrate variable y and dy. And for right hand side, we integrate variable x dx. Right? If the initial condition is given, so we need to continue with step 3. Applying the given initial condition to find the value of c. Alright, now look at example 1 from previous semester paper, semester March 2015, question 4A, Roman 1, 5 marks. Solve the following first order differential equation, dy over dx equals to x e the power of x squared minus y, given that y1 equals to 1. Right? y1 equals to 1 here means the initial condition. And when the initial condition is given, so we need to find the value of c after we integrate. Alright? Solve here means we need to make this equation free from dy over dx symbol. Means we need to integrate. Alright? Okay, when we solve using separable equation, step 1, we need to separating variables x and y. For left hand side, we need to write in terms of variable y and dy. And for right hand side, we need to write in terms of variable x dx. Right? From the given question, dy over dx equals to x e the power of x squared minus y. To separate variable x and variable y, first we can move dx from denominator here. When we move to right hand side, so we can write dx equals to x e the power of x squared minus y times dx. Times dx here comes from denominator dy here from the given question. Denominator dx here, alright, from the given question. Alright? Okay, and then for right hand side, we still have variable y here. And variable y comes from exponent. So we need to think how to move the exponent negative y to left hand side. So we need to use the properties of indices from a the power of m minus n equals to a the power of m over a the power of n. We can write dy equals to x e the power of x squared over e the power of y dx. So now we write e the power of x squared minus y into the form of e the power of x squared over e the power of y using the properties of indices. Alright? And after that, we can move e the power of y to left hand side. When we move to left hand side, so we have e the power of y dy, which is multiplication operation, equals to x e the power of x squared times dx. Now we done separating variables x and variables y, because from left hand side we have variable y and dy. Okay, e not a variable. E means Euler numbers. Okay, equals to 2.718 something. Okay, and then equals to x e the power of x squared dx. So right hand side now all in variable x and dx. Alright. So after we done separating variable x and variable y, step 2, okay, integrating both sides. Okay. So from step 1, e the power of y dy equals to x e the power of x squared dx. We just put integration symbol for both sides. Alright. And then we name as equation 1. Okay. And then we can integrate one by one for left hand side and for right hand side. Okay. To integrate the function for left hand side, okay, we can refer from integration of e the power of ax dx. Okay, equals to 1 over a e the power of ax plus c. A here means constant. Okay, let's say we replace a by 1. So we have integration of e the power of 1x dx equals to 1 over 1, which is 1, e the power of 1x plus c. Okay, if we have integration of ex dx, the answer is ex plus c. So now we have integration of e the power of y dy. We replace x by y now. So we have e the power of y plus c. Okay. So now we done integrate for left hand side. Alright. So after that, we can substitute into equation 1 here. Into here. Okay. And then for right hand side integration, we can't use this formula. Okay. Because this formula is valid for x the power of 1 only. Okay. And from right hand side, we have e the power of x squared. Okay. So this formula is not valid. Alright. Okay. So to integrate right hand side, we need to use u substitution. Alright. Okay. When we use u substitution, our u equals to x squared. Okay. And after we use u substitution, we need to differentiate. So du over dx equals to 2x. And we need to write dx as a subject. So we have du over 2x. Then we can integrate right hand side, integration of x e the power of x squared dx equals to integration of x e, and then we replace u equals to x squared, okay, times dx we replace by du over 2x. And after that, we can simplify x, okay, and we can move denominator 2 outside from integration sign. So we have 1 over 2 and then integration of eu du. Alright. So to integrate half integration of eu du, okay, we still have constant half in front. And then to integrate e the power of u du, we can refer from this formula. When we integrate e the power of x dx, it becomes e the power of x plus c. And when we integrate e the power of y dy, it becomes e the power of y plus c. So when we integrate e the power of u du, it becomes e the power of u plus c. Alright? And after that, we replace u equals to x squared. So we have half e the power of x squared plus c. Okay? So now we done integrate the function on the right hand side. So after that, we can substitute into equation 1. Okay, so after we substitute into equation 1, okay, so we have the general solution, okay. From left hand side, the answer is e the power of y plus c equals to, from right hand side, we have half e the power of x squared plus c. Okay, we're supposed to put c on the left and right side. Okay, but if we put plus c for both sides, okay, we tend to simplify c. Okay, however, this value of c is not necessarily the same and will not be 0 when we simplify. Okay, so to be safe, we just put plus c on one side only. Okay. Okay, we cannot move here because we tend to simplify c here. So to be safe, we just put plus c on one side only. Okay. Okay, this is the general solution. Okay, but the question is given the initial condition. So we need to find the value of c after this, right? Alright, from the given question, we are given initial condition y1 equals to 1, right? This means, in bracket means x equals to 1, okay? And the right hand side, 1 means the value of y. So y equals to 1, okay? The in bracket value is the value of x, alright? Okay, so if the initial condition is given, so we need to continue with step 3, okay? Applying the given initial condition, okay? This is to find the value of c, okay? We substitute the initial condition x equals to 1 and y equals to 1 into equation 2, okay? We recall back equation 2, e the power of y equals to half e the power of x squared plus c. Okay, this is equation 2 from the previous slide. Alright, if the initial condition is not given, this is the final answer. Alright, but if the initial condition is given, this is not the final answer because we need to find the value of c. Alright, and to find the value of c, we need to substitute the value of the given initial condition. In this case, x equals to 1 and y equals to 1. So we substitute into equation 2. Okay, so we have e the power of 1 equals to half e the power of 1 plus c. Okay, we replace x equals to 1 into x here. Okay, so we have 1 here. And we replace y equals to 1 into y here. And we substitute 1 here. Alright. And after that, we have e equals to half e plus c. Okay. So c equals to, we move half e to left hand side. So we have e minus half e. And it is equals to half e. So half e is the value of c. Okay. So after we find the value of c, we substitute back into equation 2 here. Alright. So therefore, the particular solution is, okay, from equation 2, we have e the power of y equals to half e the power of x squared plus c. So from here, we have c equals to half e. So we substitute into c here. So the final answer is e the power of y equals to half e the power of x squared plus half e. So this is the final answer if the initial condition is given after we substitute the value of c into the general solution. Okay, the general solution we write in terms of c, but the particular solution means we solve the value of C by substituting the given initial condition. Alright? So from the final answer, okay, when we compare to the given question, okay, there is no more dy over dx. Okay, the solution free from dy over dx symbol because we integrate in step 2. Okay. Coming up next, more examples for separable equation. Thank you for watching. Stay tuned. Bye. Assalamualaikum.